Welcome back to our Spring Boot series. In today's video, we're diving into something essential for any REST API developer: working with headers, content types, and accept media types. These are the building blocks that make sure your client and server are speaking the same language, whether you're dealing with JSON, XML, or other formats. Ready to level up your REST API game? Let's jump in and master headers and media types. In our last video, we learned how to send query parameters with our API calls. But what if our REST API needs to handle different formats, like JSON or XML? When making a request, it's important to specify the content type header, which tells the server what format our data is in, and the accept header, which tells the server what format we want the response in. You might remember doing this in Postman by adding these details in the headers section. Now, we're going to see how to do the same thing using RestTemplate in our Java code. This will give us control over how our API requests and responses are handled. Alright, let's switch over to our REST client service. Let's keep things clean and flexible. Instead of changing our existing get method in the REST client, we'll make a copy of it and paste it below. Rename this new method to execute, and we'll keep all the existing parameters. Add an extra parameter for headers. Spring makes handling headers easy with the HTTP headers class, which extends multi-value map. We'll use this to manage all our header needs. So, we'll add an HTTP headers parameter to our execute method. Now, the next question is, how do we send these headers along with our request? No worries, Spring has us covered with the HTTP entity class. This class is super versatile and allows us to wrap our request, including headers and body, into a single object. HTTP entity is a generic type, so we need to specify the type of the request body. Since we're working with a GET request, which typically doesn't have a body, we'll just specify string as the type. Now, if you look on the screen, HTTP entity offers three constructors. One that takes just the body, but since our GET request doesn't need a body, we'll skip this one. Another that takes headers, which is exactly what we need. We can pass in our HTTP headers here. And the last one takes both body and headers together, which we don't need right now. We'll go with the second option, passing in our headers, and we're all set. You might be thinking, we're using the HTTP headers class, but it needs a multi-value map. How does that work? No need to worry. HTTP headers actually implements multi-value map, which means it's perfectly designed for handling headers. This makes it super easy to add our headers without any extra hassle. HTTP headers will take care of everything behind the scenes, ensuring our request is set up just right. We've been using the getForEntity method to make our API calls, but here's the catch: it doesn't allow us to send headers using an HTTP entity. But don't worry, there's a better way. RestTemplate offers the exchange method, which is exactly what we need. The exchange method is super flexible. It lets us send headers, choose different HTTP methods, and still get the response we need. So, let's switch to using exchange. As you can see, the exchange method offers a few different options. Here's how we'll use it. First, we pass the URL. Next, we specify the HTTP method. Since we're making a GET request, we'll use HTTP method at GET. Then, we pass our HTTP entity, which carries the headers. Finally, we specify the type of the response we expect, so RestTemplate knows how to handle the data it receives. Right now, we've hard-coded the HTTP method as GET, but let's make our code more flexible by taking the HTTP method as an input. This way, we can use the same method for different types of requests, whether it's GET, POST, PUT, or any other method. Now that our REST client is all set up, let's switch over to the employee service class. Now it's time to pass an HTTP headers object to our REST client method. Create an HTTP headers object. As you can see on the screen, HTTP headers gives us a variety of methods to work with. HTTP headers class has a setAccept method that allows us to specify a list of media types. This is powerful because it lets us tell the server, hey, I can handle these formats, give me the best one you support. And when it comes to setting the content type, which tells the server what type of data we're sending, we can use the setContentType method. If we need to add specific headers, we can use the add method or the set method, where we specify the header name and its value. For our employees REST service, which is a GET API returning a list of employees, we don't need to set a content type since there's no request body. But we do need to tell the server what format we want the response in. When we want the server to send the response in a specific format, like JSON, we use the setAccept method. To do this, we simply call setAccept on our HTTP headers object and pass in media type to application_JSON. This tells the server, hey, I want the response in JSON format. Alright, let's put our new execute method to work as we code along. First, we'll pass in the base URL. Next, add the resource URL. Now, specify the response class type. Next, query parameters. Now comes the headers, we've already set these up. And finally, HTTP method.get. Everything's set up and ready to go. Now, let's start the employee service. This will get our backend running and ready to respond to the API calls we've just set up. Great! The employee service is up and running. Now, let's switch over to our REST client service and run that as well. Let's take a look at the response. As you can see on my screen, everything's working perfectly. We're getting the correct response from our API. The data is coming in just as we expected. Now you might be wondering, did the headers actually get sent? One way to check is by printing the headers in the employee service. But let's do something even more interesting. As we've seen, our getList API only supports application/JSON. If we were to set the accept header to application/XML, like we've done before in Postman, the server would respond with a 406 not acceptable error. Set the accept header to media type.application_XML instead of application_JSON. Now that we've made our changes, let's run the REST client service again. As you can see on the screen, we've hit a 406 not acceptable exception, exactly what we anticipated. You might be asking, why did we get an exception instead of a normal response? Here's the scoop: Spring is really smart about handling HTTP responses. If the response isn't in the successful 200 range, Spring automatically throws an exception to alert you that something's off. But here's the cool part: even when an exception is thrown, you're not left in the dark. Spring still gives you access to the response details, including the status code and the body, just like you'd get with a response entity. This means you can catch the exception, inspect it, and decide how to handle it, whether you want to log it, show a custom error message, or take another action. It's a great way to stay in control and ensure your application handles every scenario gracefully. Today, we took a deep dive into handling headers and content types with our REST client, and we saw how Spring smartly manages exceptions when the response isn't what we expected. In our next video, we're going to level up by learning how to pass path parameters in our API calls, a crucial technique for more dynamic and flexible endpoints. Thank you so much for joining me. If you enjoyed this video, don't forget to subscribe and hit the notification bell so you'll be the first to know when new content drops. See you in the next one.